Hi everyone, my name is Min. In this video, I will walk you through the Euler's method, a simple numerical technique that is used to approximate the solutions for the first-order ordinary differential equation. So firstly, let's understand where the Euler formula comes from by looking at this graph. So for any point, the gradient of a slope is given by the differential equation dy over dx is equal to f for x comma y. So here in my case, the slope is f for xn comma yn. However, from the basic geometry, the slope of a tangent line is also given by the calculation of rise over run. So here in my graph, rise is yn plus 1 minus yn, and run is xn plus 1 minus xn. But if you look at this, xn plus 1 minus xn is equal to the h, which is our step size. So we substitute this value and rewrite the equation. And then we need to rearrange the equation and to isolate the yn plus 1. And then we will get yn plus 1 is equal to yn plus h into function of xn comma yn. So this is the formula that is used in the Euler's method. Next, let's look at how I use the Excel to compute the Euler's approximations for the differential equation dy over dx is equal to a squared plus 1 over y, where the values of y is greater than 0, with the initial values of y is equal to 1 and the initial values of x is equal to 0. So let's assume the step size h is equal to 0.1. So this is the column for the values of x, starting with its initial value is equal to 0, and then we add step size into its values until we get the x value is equal to 1. Next, I found the approximate values of y by using the Euler's formula. Then this is the column for the approximate values of y. So if you look at this blue column, this is the actual value of y, and I calculated this by using the formula y is equal to square root of 2x plus 3 plus 2x plus 1. So to better understand this, let's look at my handwritten calculation. So dy over dx is equal to a squared plus 1 over y is the equation that we need to solve. So we rearrange the equation and then integrate both sides. Then we will get y is equal to the square root of 2x plus 2x over 3 plus 2x plus c. Then we are also given the initial values of x is equal to 0 and the initial values of y is equal to 1. So we need to substitute these values to find the value of c. And then after finding the value of c, then we need to rewrite the equations with the known value of c. So assuming the step size h is equal to 0.1, so the next values of x after its initial value is equal to 0 plus 0.1, so which is equal to 0.1. So to find the next accurate values of y, then we substitute all these values into the equation, and then we get the value is 1.0957. Then let's look back to the Excel sheet. So this is the approximate values of y, which is equal to 1.1, and this is the actual values of y, which is 1.0957, with the approximation error of 0.0042. So this shows that the Euler's method gives a really quite good approximation. However, if we use the bigger step size, let's see, then we will have a larger approximation error. So from this, we can note that the smaller the step size, the more accurate approximation that we can get. So this is the end of my video. I hope my video helped you understand better about the Euler's method. So thank you for watching.